In winter, an EV can feel dramatically less efficient, especially on short trips. And I'm not talking road trips where range really matters, but on everyday driving, errands, school runs, or quick commutes. Why does this happen, and what's actually going on in those first few minutes when the weather is cold? In this video, I'm going to explain why winter driving can feel so inefficient on short trips, not as a problem that's specific to EVs, but as a result of how energy gets used at the beginning of a drive. And by the end, you'll understand why short winter trips are inherently less efficient and what actually helps recover some of that efficiency without changing how you drive. When people talk about winter range, they're usually thinking about road trips, how far the car will go before you have to stop and charge. That's a real concern in that context, but most winter driving isn't road trips. It's short trips close to home, and in that situation, you're almost never in danger of running out of energy, especially if you can plug in at home. And before we go any further, one important thing. This is not about avoiding short trips. Car manufacturers have warned about short trips for decades, gas cars included, not because they're bad to do, but because they're inefficient. Short trips are a normal part of driving, so the question isn't whether you should make them, it's why they cost more energy in the winter and why EVs make that cost easier to see. On a cold start, a surprising amount of energy gets used before distance even matters. The cabin needs heat, the battery needs to warm up, and systems that were idle overnight all come online at once. None of that depends much on how far you're about to drive. Whether you're going 3 miles or 300, the car has to do those things first. That's what people usually miss. Think of that early energy use as fixed cost. On a long drive, that cost gets spread out over many miles, so it has much less impact. On a short drive, it's concentrated into just a few miles, which makes efficiency look dramatically worse. Nothing unusual is happening. You're just seeing a large upfront energy expense divided by a very small distance. Gas cars behave the same way in winter. They're less efficient on short trips too. The difference is how the inefficiency shows up. Gas cars mostly show efficiency as miles per gallon, which blends everything together. EVs show energy used more directly and more immediately, especially right after a cold start. Even when an EV shows miles per kilowatt hour, the early energy use is still front and center. You see it happening instead of it getting averaged away. That doesn't mean EVs are behaving differently. It means they're being more transparent about it. That transparency changes how the experience feels. So when the display updates quickly, your brain treats it like feedback. You're not just driving, you're watching the car react in real time. On a short winter trip, that means the least efficient minutes get the most attention. The number moves before the context is time to catch up, and so what feels like a warning is often just early information presented without much smoothing. The car isn't saying this is bad, it's saying this is what's happening right now. This is where winter driving in an EV can feel misleading. On short trips, the display is dominated by the least efficient part of the drive, the beginning. So even though the total energy used is small, the efficiency number looks harsh. And because you're usually only a few miles from home, the experience feels worse than reality. You're not close to running out of energy, but you are seeing early energy use very clearly. So here's a simple way to think about it without changing anything about how you drive. Imagine 2 winter mornings with the same car and the same driver. On one morning, you start the car, drive a few miles to run a quick errand, and come straight back home. The car spends most of that trip warming itself up, and the drive ends before efficiency ever has a chance to settle. On another morning, you make 2 stops back to back. Nothing about your driving changes, but the second part of the trip happens after the car is already warm. The total distance might not be very different, but the efficiency reading almost always looks better the second time. Not because you did anything differently, but because the expensive part of the drive already happened. That's the effect people are reacting to. Home charging changes how you should think about it. On a road trip, range matters because you're managing distance between charging stops. Efficiency and range are tied together. On short trips near home, the risk usually isn't there. You're not trying to stretch the last few miles to a charger, you're just driving, then plugging in later. So the question shifts. It's no longer, will I make it? It's, why does this look so inefficient? And the answer isn't failure or misuse, it's how energy gets spent early in the drive. Once the car is warm, efficiency improves on its own. The cabin doesn't need much energy, the battery is already operating comfortably, the expensive part of the trip is over. On short trips, you often stop before you get there. That's why efficiency sometimes looks much better on the second errand, even if nothing else changed. Not because you drove differently, not because you optimized anything, but just because the car started warm instead of cold. So when an EV looks inefficient on short trips, it's not telling you something is wrong. It's showing you upfront energy costs very clearly. Costs that every car has, but that EVs make harder to ignore. Once you separate range from efficiency and road trips from everyday driving, the behavior makes sense. Short winter trips are inherently less efficient. That's normal. What changes with an EV isn't the physics, it's the visibility. And once you understand that, the display stops feeling like a verdict and starts feeling like information. You're not being warned, you're being shown how energy is being used. And that makes it much easier to interpret what the car is telling you. This is Wrench and Reason, where we explain how modern cars work. Thanks for watching, and I will see you on the next episode.